we are Vegas programmers. We are part of Tech Alley. Thank you all for coming out today. Today we're going to be presenting two talks. One is going to be presented here by Devin, which is the Git code update start to finish. We also labeled it as Git flow up on the website. And I will also be doing a code refactoring talk. If there's any questions during, are you cool with them just asking? So yeah, just go ahead and stop either of us while we're presenting if you have any questions. If we feel like in future slides we'll answer your question, we'll probably point that out and then keep moving. But yeah, here we go.
Yeah, I got this one.
Okay.
I think I'm good. Can everybody hear me?
Yeah.
So this is
not hearing over speakers.
What's that?
Not hearing you over speakers.
No, not hearing over speakers. Okay.
Your voice is loud.
Oh yeah.
Now?
That's only for the video.
Yeah, that's only for the video. This is for the speaker that's right behind
Okay,
you.
well. Can you guys hear me? Because I can't hold this up and do the thing at the same time.
Okay.
Can you speak up a little bit?
Yeah.
I'm hearing aids.
I'll try, yes. I will try to yell. So this is a demo that, last time I did a demo on Git, and people are actually on a couple things, but it was more abstract, and people said they wanted a more detailed presentation, so and a more code-based. So I built this new presentation, and what we're going to do is we're going to actually update a website from start to finish, an existing website, using all the tools that you need to do that. And since we're going to touch on a lot of different subjects, if you want to ask questions during the, I can hold this up now. If you want to ask questions about different technologies we're using or whatever, that's fine. I don't know if this is going to take the full half hour to 45 minutes. So that's kind of what the presentation is. Also, I forgot my book, so I have to have the presentation steps up here because I forgot to write, or I forgot the book that has them written down. So you guys will get to witness the instructions that I wrote for myself. So, because I only have one screen, so. Okay, does anybody have any questions before we begin about this presentation? So what we're going to do is, I have a website. Oh, and what's the Wi-Fi in here? I don't know if I have it hooked up or not. We are going to need to hook to the Wi-Fi network. Whoops. I hate Windows 11.
I believe it's Artifice Guest.
Yeah. I have recently been updated to Windows 11, so I still can't find my way around it yet. Anyway.
Did you come from Windows 10?
Yes.
Yeah, I think Windows 10 is better than 11.
Every time they do a new update, it's harder to find everything you need. It's like, it just becomes a little bit harder, you know, with every update. So, all right. So let's first take a look at the website we're going to update. This is my personal website because I have not set up a test website for this demo yet. If I start giving this demo regularly, I will set up a test website. So this is my very exciting website. As you can see, it does not have a huge amount of content on it. It has my resume on it, and it has some links to various things. You can go to my LinkedIn profile. You can send me an email message, but you can go to my GitHub site. So this is my website. And so what we're going to do is we're going to go ahead and change the text color and the background color on this website. And we're going to do it from start to finish, starting with nothing on our local machine, including getting the source code, updating the source code. In this case, it's going to be very simple source code, but we're going to update the source code. We're going to push it to Git, make a pull request, approve that pull request, and then witness the actual CI/CD pipeline, do the update of the website, and witness it. So that's kind of in a nutshell of what we're going to do. So any questions so far? This website is an Angular website, not that it really matters all that much for this demo. I'm going to try to keep this somewhat technology agnostic, except for the fact that we're using Git, because this demo is kind of centered around Git. Okay, any questions? All right, so next thing we're going to do is we're going to actually visit where it's hosted on Azure. This particular website is hosted on Azure. I'm using a thing called Static Web Apps. This isn't a talk about Azure, but I will talk a little bit about some of these side technologies. A static web app is the new thing that Microsoft has come out with for hosting single-page applications. The difference between this and a regular hosted website is that you don't need to install IIS or any other hosting technology yourself or manage it yourself. Static web apps works because Angular does its own page changing and all that. It's automatic. The limitation is that you can't call any REST API you want. You have to call Azure. You have to call a specific. There's a way to set up Azure functions that you call from it. But it is a very convenient technology, and there are templates on GitHub for setting this up, so I didn't have to do a lot of work to set this up. Yes?
Is there a way we could fix the screen? It's like...
Oh, is it messed up?
Yeah.
I don't know. Maybe.
Where's the projector?
The projector hasn't been straight this whole presentation.
Oh, there we go. There we go. Yeah, my next presentation, I'm going to bring a HDMI cable. An HDMI extender. Unfortunately, we don't have one right now, so we're kind of tethered a little bit here. Anyway, okay. Is it? All right. So, this is the hosted site, and so we're also going to look at the site on GitHub. And I think it's private. I think I have this repository marked private currently. I do host on GitHub. This is basically an Angular application. There isn't much else since I don't make it public, there's no README page or anything for that currently. At least I don't make the source public. So, any questions about this? No, moving on. Okay. Okay, so our next step is we're going to go ahead and clone this to the local machine. And I don't know how many of you are familiar with GitHub, but when you clone something to the local machine on GitHub, you go to the repository that you have and you select code, and then you copy and you can use the copy button here too. I always forget to do that, but you can get code, you can get stuff through SSH, HTTPS, or GitHub CLI. I've used these two. I've never used GitHub CLI. SSH is a little more secure and businesses like it, but you have to set up keys and all this stuff. So for us, we're just going to use HTTPS. So next thing we're going to see is how to actually clone a repository in Git. And I apologize if some of this is simple. Some of this is stuff people already know, but anyway.
It's okay.
Yeah.
Terminal text just a little bit bigger. That's possible.
Make the what? Terminal text bigger?
Yeah, just a little bit. Just control and mouse scroll up.
Oh yeah. Thank you. Thank you. All right. So I'm going to try to yell again, because I can't type and hold the microphone at the same time. So one thing about a Git repository is you can clone it to pretty much wherever you want on your machine. There's no real requirement for any particular location, and there's no link to anything outside of it doesn't link to anything outside the folder you put it in, so you can put multiple copies of your website or multiple copies of your code on your machine. And that's basically what I'm doing now. Is I'm going to create another temp folder so that I can put it here. So when you clone a repository in Git, you do git clone, This is a PowerShell window, in case you're wondering. You can also use Bash. Git has Bash. There's a lot of different command lines. So basically, I'm just pasting in the string that I got from Git, and I'm hitting Git clone. So basically, now I've basically just, and you can, there are different options you could specify. In this case, I didn't specify any options, so I basically just got a subfolder with the repository in it. Any questions about cloning a repository? Now you can see, once I switch into the repository, you can see that it has a GitHub folder, which makes it a Git repository. And it's basically copied all the files. It's basically downloaded all the files from my Git repository. And as you can see, we're in the main branch currently, which is the main branch of the project. In another demo, we'll see how to set up these projects and that kind of thing. But for this demo, we're basically working with an existing website. Okay. Yep. Okay, the next step is to install the dependencies, and this kind of depends on what technology your website is built on. Angular is a NPM technology, so we're going to do an NPM install. If it was Visual Studio, you would do it would be done during the build. Java, there's Java libraries that get installed. I don't know how to do that, but this is very specific to the technology you're using. But whenever you clone a new repo, you would probably have to do some kind of step like this. And what this is doing is going to the NPM website and pulling down all the packages I have defined. So everything that's not my code, essentially. Now, this will take a second or two. I tested it earlier, and hopefully the Wi-Fi isn't too slow. I wanted to make sure this wouldn't take very long, but any questions so far on what we've covered? No, unfortunately. Okay. All right, there we go. Great. Okay, so now we have a working repository and we're ready to go. Next step, and I use VS Code for Angular development. You can use anything you want. There's no rule that says it has to be VS Code. And of course, it's going to ask me whether I trust the authors of this, and since I'm the author, I do trust myself. So, all right, this is VS Code. This is not a demo specifically on VS Code, but this is one of the technologies we're going to touch on. And I don't want to go into too much about Angular, but next thing we're going to do is we're going to actually see the website run locally. Because if you, except you don't type 4 afterwards. So one thing about Visual Studio Code is it has this built-in terminal support. So Git is basically a command line technology that has been ported to different editors. So one thing I like about this is you can kind of mix and match. If you like using the command line for Git, you can do stuff in the terminal. If you like using the Git extension, you can do that too. So this right here is the source code. I'm not going to go into it in too much detail because this is not a course on Angular, or this is not a talk on Angular. Oh, whoops. Okay, oh good, it's working. Okay. So now we're going to go ahead and go to localhost. Aha, so we can see my site running locally. So now we can make changes to the site if we want locally and test them, etc. But the next step we're going to do is, because I wanted to kind of show the idea of creating a feature branch and doing a pull request. Now since it's my website, I could just modify main, test it, push it up to thing, and it would be accepted, and that'd be fine. But if you're working in a different environment, like a business environment, they're probably not going to let you push code directly to main. So part of this demo is to see how to do, so with Git, you can do it in the command line, you can do it in the editor. There's a lot of different ways. Different editors have different integrations with Git, but if I remember correctly, -B is the way to create a new branch. And this is Git creating a branch. So what we just did was we created a new branch called test feature, and we switched to it.
Text a little bit bigger.
Oh, yeah, let's see. Don't know how to do that.
VS Code, it's in view.
In view?
Appearance. And then you can see that the hotkey is control plus equals for zoom in.
Oh, yeah, zoom in. Yeah, right. Very good. Control plus. Oh, we just went the other way. Sorry, what was that? View?
It's control plus equal.
Control plus equal.
And then just tap it a few more times.
Oh, yeah. Okay, can everybody see it now?
Yeah.
Yeah.
Okay. This is one of the problems with using command line is that you run out of space pretty quick. So anyway, so we see that website running now. So what we're going to do, we witnessed the website running. What we're going to do is we're going to go ahead and change the color of this text, of all the text in the site, as well as the background. Because it's a simple update and we don't really have to change much code, and it makes it a little bit easier. Because I don't want to have to go into the details of how you use, how to do TypeScript programming, because that's not what this demo is about. So what we're going to do, anybody have a preference? I'm going to go ahead and make the text color black. This is my live website, so I don't want to make it anything too crazy. Anybody have any preference for what we might want for a background? Tan? I don't know if there is a tan. Well, that's okay. Tan. Works for me. Works for me. Okay. So now we're going to save it. And one nice thing about the way this works, and as you can see I got two terminals running, is it should update the local website on the fly. And it does not. Okay, let's try that again. Did we save? Tan black, okay. Oh, because I probably am looking at the one running on Azure, which obviously will not be updated yet. Okay. Ah, there we go. Okay, so now my website has a tan background and a black, but this is only localhost home. So now we need to figure out how to get this code up to the server. And the way we do that is, now again, and you could do just about anything in the command line or in the editor. So if I look at my editor, I can see, okay, styles is modified, and I could do a commit here with a commit message. But Git likes things to be staged first. You can actually do things without staging. Staging allows you to only check in some of the files that you have modified. So you don't necessarily have to check in every file. So from the command line to stage something, you do git add and then the file name or period. From here, I could do stage changes. But since people were interested in learning about the command line, I'm going to go ahead and do it from the command line. And as you can see, the editor immediately recognized the fact that it's now staged. And what we can do is, this I usually find is easier to do in the editor, but you can also do it here. Git commit -m, make color change. I think it might open an editor, so we got to be a little bit careful. Okay, so now what we've done is we've used git commit. You could, like I said, you could also do this. This branch that we created is not on the server yet. I don't remember the exact command to publish a branch from the command line. We can nice thing is Git will be nice enough to tell us. Git push upstream open. So what pushing does is it basically takes the commits that we made and pushes them up to the server. Very good. So now if we go to GitHub, you should be able to see this. Okay, we're going to go to my website here. This is, and you guys probably want me to make it bigger again. Oh, there we go. Wait, okay. Okay, let's try that. Did everybody see it? Is that big enough for everybody to see? Yes. Okay. And so now we're going to, so we made our updates to test feature, and we now see, you can do this manually, but it's nice enough to tell us that there is a change made recently. And so I'm going to open a pull request. And a pull request is basically a collaboration tool between different developers. And if I was in if it was an organization, I would probably tell other developers in my organization that I had a pull request out. They would review it, and we could collaborate. So I'm going to create the pull request. And we can see, and this can be done in other tools too, like Azure DevOps, but in this case in particular, it's GitHub. So one interesting thing you could see is once you create a pull request, GitHub, this template that I used has actions pre-set up, but you can do it yourself too. What it's actually doing is making sure the build actually runs. It's got a gated check-in built into the pull request process. And again, I didn't have to set this up because I could have, but if you use a template, it sets all this up for you. But you can customize it to anything you want. So what it's doing right now is making sure the build succeeds. It won't actually push it to Azure yet because the pull request is not approved. So here's our pull request. And so, as you can see, it is running, and it will take a minute for this to happen. Does anybody have any questions while we wait for this? I was going to try to figure out how to disable this, but I didn't. Questions?
Maybe just to maybe catch people up, but what is Git?
Git is a source control system, a distributed source control system. I hope that everybody's familiar. Is there anybody who's not familiar with Git at all and wants me to explain a little more? Sure, I can do that. No worries. Git is the source control system that is most in use today. There have been other source control systems over the years, but Git is the currently used one. A source control system basically allows you to put versions of your source control or any other files for that matter on a server and share them with other people, and to keep track of previous versions, as well as these days you have GitHub, the GitHub website, which works with Git and can do builds and all kinds of other stuff for you. The main thing about Git that's different than other source control systems is that, as you saw, I pulled the Git repository to my local machine. When I did that, I created a complete history of my project and everything else locally. So once I did that, this becomes a completely standalone project with complete history. So I could view the history looking here. I don't need any connection to the server to work, to do anything except the push step. So I could have done the commit, worked on it all day, whatever, even if I didn't have an internet connection. Then later on, the push step is what actually pushes that information to the repository on the server, which is basically just another copy of the Git repository, except that it doesn't have a working directory. That's the one difference. And the one on the server is typically the one that people share and that is considered the kind of golden rule. And it's usually hosted in GitHub or Azure DevOps, but it technically doesn't have to be. You could actually, I've seen cases where people just hosted their centralized Git repository on a server and they just put it up there and that's it. So you don't get pull request support or anything like that.
I have a question.
Yes.
So the Azure CI/CD thing you have set up, is that most of that just automatic, or is there?
Yeah, it's from a GitHub template. We'll take a look at it in a minute when we push. But yeah, you can set it up yourself, but I didn't want to, so I use the template. It's not terribly hard to do, but you do have to be familiar with YAML. I don't know if you guys know what YAML is, but it stands for yet another markup language, which is kind of funny. But Anyway, so now we see that all the checks have passed and we're good to go. So normally, if I was working in a multiple user scenario, there's probably rules saying that I can't review my own code and that other people have to approve it. But this is technically this is me, so I don't have to go through any of those steps. So what I'm going to do is now merge, and I didn't go over this, but the pull request basically says I want to merge code from test feature into main. So what has just happened is that Git has automatically done a merge commit, and I think I left it at, there are different options you can use for different types of merge commits, and I won't go into a lot of detail about that, but because that's kind of another talk into itself of how to do merge commits. But we can see now, if we want to look at the details, we should be able to see, let's see. You can see in main, let's see, history. I usually use Azure DevOps, so.
So you go to the commit itself.
What's that?
I think if you go to the commit itself, you can see the diff. Is that what you're looking for?
Yeah, I was just going to look at the history, but
You can click commits.
Commits under the green button.
Yeah, under the code button.
oh yeah,
Well, the green code button.
oh yeah, good point. Yes, thank you.
The,
Yeah, you're right. Thank you. Yeah, you can see the commits. So what happened was we had our commit, which is make color change, and then we had the pull request merge commit. Another way to do this too is you could do a squash commit, which this color change one will not appear in the history of main. And I don't want to go into the details of how Git does branches because that's a whole large talk in itself. But suffice to say, Git, it's very easy to create and merge branches at any time, or create whatever branches you want whenever you want. They're very lightweight. They're nothing special. They're basically just a pointer to a commit. So it's one of the cool things about Git. And probably in another talk, I'll talk more in detail about Git branching and Git branching strategies because it's a topic unto itself. So. And now we'll see the actions here. What has happened is that because we've merged this pull request, there's a build and deploy job going on. And what you can see here is this has several steps. It's based on a YAML pipeline, which is here somewhere. Not that
workflow file,
Yeah.
left bar, down.
Oh yeah, good point. Thank you. Anyway, like I said, I'm not that familiar with this. This was actually built by the template itself. At some point, I'm probably going to have to make changes to it, so I'll probably have to know exactly what this does. But this is basically a pipeline to send a website code to the Azure website in question. And we can see that it's done, so looks like we're good to go. It is closing the pull request at this moment, and if we're lucky, we'll see that the website, and there it is. It's already the website is already updated. So the live real upsite. So that was kind of the how to do a code update in GitHub. Yes.
Can you show a diff?
Sure. Of the changes?
Just the diff of the changes.
Sure. Whoops, I think we got small again. Oh, yep, there we go. They were very simple in this case. Let's do code. 25 commits. Let's do make color change. Yeah, you can see the, this is another thing you can do by command line too, actually. I have found that I'm not all that thrilled with the command line diff tool. Diffit is one case where an editor really comes in handy. And Visual Studio Code has pretty good, and as does Visual Studio. Some people use the ReSharper, the JetBrains tools. There's all kinds of different good diff tools. And we had a talk some time ago about merge conflicts, and so we could do a separate talk just on how to handle merge conflicts, but in this case there were no merge conflicts. It was just a simple change, so nothing earth-shattering then. How are we doing on time? How long did it take us? Half hour?
Yeah, about.
Half hour? Okay. Was a question? Yes?
Does the Azure static website, does it have like a preview feature so that it builds your merge request before you merge it into main?
I think you probably can. I think it probably has slots like anything else. I know their regular websites do, and I assume that the static does. I have not used. I have not looked into this hugely.
I think the way Azure does it is you basically have to have just a staged version of your site, and it pushes to that site, and then it pushes to the next one once you're okay with it. I don't think it does anything special.
So you have to have like environment stuff already.
Yeah, you kind of have to like stage in dots or something, have a different subdomain maps, and you have to push it to that to do validation. Or you can do your automation checks, but that for manual, I don't know if it has anything.
We touched on about 20 technologies in this talk, so there's, but yeah, there's a pretty good documentation on static websites because I was able to set all this up in a couple hours.
Have you used any other hosting providers?
I have always,
Or
what was the one you were mentioning?
Netlify?
I haven't used that one. Usually AWS and Azure I consider kind of the true premier ones. This website, the domain registration is actually on AWS because Azure doesn't have, at least as far as I know, doesn't have domain registration. You could also host on AWS using a standard website, or the version of this for AWS is currently just a S3 bucket. Basically, you just put it in S3 bucket and then you have a URL to it, and boom, it shows it, and you're done. So. I don't think this is I think Microsoft's answer to way of doing that. And if you've ever dealt with IIS, you don't want to deal with IIS if you don't have to, especially on an Azure application. So this, in my opinion, is a miracle, even though there are limitations and you have to go, like if you want to call it REST API, you have to go through Azure. You have to go through the Azure API. You can't just call it.
You can't call like an external API directly?
No, you have to go through an Azure function, basically, because it doesn't have the full web. It doesn't have a full it doesn't have a full hosting mechanism on it. You can, like, on the tier that I'm on, because it's cheap, you have to call a specific Azure function. So it's very limited. But if you go to the little higher tier, then you can actually install an Azure function collection, etc., and then you can pretty much do whatever you.
Use it to host like a live production site?
You could. We do that. Microsoft does it. I contract to Microsoft, and they are using this for some of their. It's not their external sites, but their internal sites. So you could, as long as you're willing to go through the Azure functions to communicate with the outside world. Okay. Anything else? Let me take, while we have a second, is it okay if we have a second? Could I was kind of trying to get a feel, do we have, of the technology, do we have any C# developers in the audience? Just one, okay. JavaScript? Python? Okay, everybody does Python. Java? Okay. Just trying to get a feel for what talks. If people have if people have suggestions on what the next talks might be, or if you want to learn about, I don't know, different topics. Git has a lot of topics, but a lot of them are pretty low level. So this talk was actually very easy to write, but a lot of them aren't quite as easy.
I really like that GitHub Actions thing, and like building a pipeline or a workflow. To me, that is like I would demo it.
Yeah.
That's a relatively new thing. It's kind of, I think, patterned after Azure DevOps. Azure DevOps has it much more powerful, in fact. Like at Microsoft, they use Azure DevOps for everything. GitHub Actions, I believe, are not as powerful. but I think Azure DevOps is pretty expensive for just using at your house.
Planning on doing this for the group that mostly knows like Azure technologies. Is that who you're tailoring this for?
I'm tailoring this for pretty much everyone who wants to learn what a developer does every day. Essentially, so what you just witnessed is pretty much what at least most software developers I've always known. This is what they do all day: is change code, upload it, do pull requests. So this is kind of meant to be an end-to-end demo on software development, essentially. I was also trying to keep away from specific technologies, because if I do a C# demo, only one person in the audience is really going to care. So.
Just going back to your first speeches I heard you say, it's like you start building these technologies in the beginning and they just kind of like grow over time. So maybe like I'm just kind of curious on how to like set up the pipeline in the beginning and maybe have like a couple, if you were to continue like developing this into a full product or whatever, maybe like here's like the early stages of the pipeline versus like the middle stages once you've like added in a couple more features, and then like the late game kind of status with all like the bells and whistles and here's the full shebang thing.
Yeah, you could. I mean, you'd modify the YAML, obviously. If you're going to stay with GitHub Actions, you would modify the GitHub Actions to do more stuff. You could also, Azure DevOps will actually handle stuff on the GitHub repository as well, and probably vice versa too. So you could, if you wanted to do, if you say, oh, I really like Azure DevOps, or Jenkins for that matter, there's a million different CI/CD pipelines and build and deployment tools out there. So pick the one you like. I mean, for me, this is a simple website and I'm paying for this, so I didn't want to spend, I probably spend $5 a month to host the thing. That's about it. So you can get into money pretty fast if you start doing stuff. If you start using more complex tools. And I'm not planning to sell anything on here. This is not going to sell anything anytime soon. So I might put a blog and stuff on here, but the problem with it is you got to watch security at that point. So the minute the website is not read-only, the minute you allow people to leave comments and stuff, then you got to start thinking about security and bots, and like they were talking about in the last talk, and making sure that you don't get people selling Viagra and stuff on your site. So it's easy to get that kind of thing. So anyway. That's it. Thanks, guys. See me afterwards if you want a suggestion on another talk.
So today I'm covering the topic of code refactoring. I don't actually have like any real examples, mostly because all my good examples are proprietary code that I wrote for a company. But we're going to talk about like some of the strategies and the reasons why, reasons why we did the refactor, and also what was like kind of like the end result. But first things first, what is code refactoring? Well, I tried to simplify this down to a bullet point. It didn't quite work out, as you could see. But it's basically, the idea is, don't worry, these slides will be up, so if you really want to go read that entire wall of text, it'll be available on a link. But here's how I broke it down. So it's basically, why are you refactoring? Because what is code refactoring is you're altering the code to be simplified or some other things. But in this case, we're trying to improve code readability, reduce complexity, enhance performance sometimes. Most of the time though, it's mostly for like a developer's experience, in like that the code makes sense and is readable and maintainable. Because sometimes you're going to end up with cases where like the code is just so far gone that you feel like you need to rewrite it, but in all actuality what you probably actually want to end up doing is slowly refactoring it over time. We'll actually go more in depth in that here shortly. So how to refactor? Start small. Believe me, if you try to do massive refactors all the time, it's everyone on your team is going to hate reviewing your PRs, and I speak from experience. It'll be when you put up your PR, you notice like everyone doesn't even look at it until like a few days later your manager kind of goes and rubber stamps it and goes, well, the tests ran. So start small. Also, like I said before, automated tests, like especially when you're like doing this, make sure your tests are solid, because when you have solid tests, you can make these changes to your code and know that they are functioning how you expect, or how your users and you expect it to work. You'd be surprised how often someone will be like, oh, I bet I can refactor it this way, and then they'll go and they'll make like this change, but then the test fails. Well, the thing is, when you're refactoring, you're not trying to add new features, you're not trying to add functionality, although that can sometimes be added on as part of your feature branch, much like how every time, we're talking about changing certain standards, maybe we bring in different parts that don't necessarily have to do with that standard. Also, keep records of the changes for auditing and reviewing. Luckily, this is probably already done for you if you are using a version control system like what we just saw with Git or Mercurial, or I forget what the other ones are. I really only know Git. TFS. Oh, TFS, that's another one. But it's like that will actually keep a log of all the commits in the history. So if a refactor does go terribly wrong, maybe a test didn't catch it, QA didn't catch it, and now it's off in production and it's causing havoc, well, you actually have the ability to go back in time and bring back what was working versus what wasn't. Also, talk with your team members. If you're about to do a refactor, make sure you are talking with your team, because just because like a pattern makes sense to you that you want to implement doesn't necessarily mean it'll make sense to your whole team. In a lot of this time, like when you're working with code, you're working with a team, so be a team player. And, integrate and test. I'm not sure how many times I need to add tests to this slide, but test it. Okay, so now we're going to go over some of my real world experience, because this is the closest thing that I have. So it's kind of shocking when I worked at a company and they said that their application was a 20-year-old application. And I went, programming hasn't been around that long, has it? Well, fun fact, it has for a long time, because the 80s or 70s actually. Let's just scrap the history lesson. Programming's been around a long, long time. But because of that, it was built on previous examples of what were best practice that are not best practice today. Like one of the things is so to be a little bit more clear, this was a PHP application. It did requires everywhere. And if you're part of the PHP world, you know that there is a new standard, so you can auto-load your modules. And what's funny is some people actually don't even know that, because they know that they just install Composer, and then they do like Composer install, and then it just magically all shows up, and it's like you just need to put the namespace in the top of your file, and then it's there, right? Well, this was before that, well before that. So one of the things that we did is we sat down in a meeting, with the architect team and the engineering team. It was a relatively smallish team. We're talking maybe 20 people total for like all this. Like that's not including the business people. The business people outnumbered us like 10 to 1, because there was like 200 marketers while there was 20 of us tech guys. Had to keep the lights on, right? We have to keep this application going. How do we handle this? Well, first part is we talked about it. And then that's when we went, well, before we even want to do anything, we have to write tests on all of this. Because another thing with 20-year-old application, it was written by a kid in a college dorm room, not ever thinking about a unit test. So, first step was make unit tests, make end-to-end tests as best we could. End-to-end tests ended up being the winner. We went with a thing called BHAT with Selenium, which is a BDD development framework. It allows you to write user stories. So it goes like a user is going to go and log in and access their profile. So then a bot would take Selenium, which is a headless browser. It spins up that headless browser and will then go through and log in through a login form and go to a profile page. Can it actually get there? Excellent. That's a successful pass. If it couldn't, where did we go wrong? So that was like step one, was unit tests, flow tests, things like that. Then we came back into the meeting. Again, collaborate. We talked it through again, and we started deciding how can we start cleaning up the code to bring it into a modern era where when we're interviewing people and we're asking, do you know what a require is? And then they go, what? Like, that was an instant, like, unfortunately, we'd have to pass on that one because they would struggle a lot in our environment. How can we get the code to be more modern so that we can get new talent onto the project, right? Because like you don't ever want the project to stagnate and die because you couldn't produce features. And there's not a lot of people that want to deal with 20-year-old cruft. So we start going through, and like the first thing we did is we implemented like a service container and stuff like that, right? But these were all small incremental changes is kind of the pattern here, right? Where it's, we would meet, talk through it, say this is what the next step should be, the next logical step, and then go and execute that step. And success or fail, meet again, rinse, repeat. Right? Like that's the big takeaway, especially when you're dealing with really old application. We ended up getting so close to Symfony that we were actually able to install Symfony, move our controllers over, and no one could tell that this application had been around for 20 years. That also took us 5 years to do. Long time. The other one is the cutting corners application. I'm sure a lot of engineers that have been here today, I don't know about this room, but maybe, have like been asked, hey, can someone come like work on this project? Or maybe you've interviewed at a company and you come in to work on this project and you notice it's all one file.
Yeah.
And you're like, what happened? And they went, oh, well, this dude wanted to charge me like $80 an hour for this application when I could just go to this firm over here and they were offering it $5 an hour. Well, you know, it got the MVP out, it got the clients, right? It got the customers there. Now they have the money to fix it. So they hire a bunch of people like myself on. And this one, I gotta say, is by far like the time where I'm like, maybe the answer is a rewrite, but no. Again, implemented unit tests and implemented end-to-end tests, but there wasn't really much talking in meetings for this because, you know, we were 5 people and we were all working in the same cubicle space. If we ever needed to talk about something, we just all kind of like knocked on the top of the cubicle and we all stood up and went, yes. So again, you know, make sure you're working with your team, you're working close together. This one is like, you know, the first steps were, how can we get it so all the pages are not one page? And when I mean one page, again, this is a PHP application. I apologize. Almost all my history in programming is PHP. And just because you can make it all one PHP file doesn't mean you should. So, you know, that's when we like brought in a framework because we felt like that was like the first step, getting it so that the page was mostly like, if it's a new page, go to Symfony. If not, run the logic that we had from what was there. And like, you know, so like that was like the way we kind of figured out is if we fork it, we can slowly kind of bring the logic over page by page until we got it all in. The only parts, by the time we were done, the only parts that were in like that original file that was the one file was the header, footer, and then we just migrated those over to the template and went, congratulations, we have finished refactoring this application. And that took a long time, but it's unit tests, end-to-end tests, talk, figure out which pattern you want to go with, and most of the time the pattern is, what is your favorite framework that everyone agrees on your team, and go with that pattern slowly. And then eventually maybe you can get the application to where it can just be moved fully into that framework, and then again, all the new hires never know all the pain and agony you went through trying to get that code from being that $5 an hour application to the $100 an hour application. And then this is the one that I always tell people, absolutely avoid it at all costs if you possibly can, but sometimes you can't. There's always going to be that one application that everyone in the room looks at and goes, we can't. There's no solving this. There's no fixing this. We cannot, extrapolate away the logic. We can't, break it down into objects. We can't break it down into microservices. It's stuck. So to kind of give some context and some clarity on this was back actually when I was kind of like a programmer with a DBA style job, right? So I'm not sure if people knew this, but back in the day, there was an Apache module for the Apache web server called mod PL SQL, where it would log into your database and it would run a stored procedure, just like how you run your Python or other scripting languages with your FCGI front end, except for instead it's logging into a database and running a stored proc, and that stored proc is then returning your HTML. Yes, this is a thing that happens, and it's still around to this day, kind of, except for now it's called Oracle Apex. Yeah. So I wasn't around for the start of this, but even when I came in, and I'm always a curious person, I would ask, why? Why are we doing this? Why did we think a rewrite was the good option? And the answer is mostly because when you go from olden day Oracle to modern day Oracle, the PL SQL is nowhere near intact enough to run in a newer environment. So to get the newer functions, you have to essentially rewrite the application. And this is the problem if you put your web logic into your database logic, well, you're going to run into this where it's like, as much as we wanted to, we couldn't get it to where we could just kind of like migrate functions over, because then we would have had to run 2 Oracle databases. That's double the cost, because Oracle, you're paying per core on each server. So now we have 2 servers that are running the same application. And that would be a costly endeavor, especially when you're handling like tens of thousands of people across the globe. So sadly, the answer was rewrite. This is a form of refactoring, is to just rewrite the application. But again, I'm going to say that like this should be like the last possible thing you and your team ever think is possible. Because this one, I came into it, it had already been 5 years into their rewrite, and I left, and it wasn't until 6 years later when I talked to my friends that were still working there, that I met there, that it had finished. That's 11 years to rewrite the same application. It's a long time. That's a lot of money.
It actually worked after 11 years.
Well, yes. They ended up adding features 8 years in, because they were like, well, maybe we should add features while we're doing this rewrite. And that inadvertently always adds time. Do I have any questions?
What I was going to add was, when you talk about rewrites, I mentioned this in my talk last month actually. You were mentioning that normally when you do refactoring, you do it in small pieces, right? You do like 10 small pieces. Well, to me, when a rewrite is necessary, if you look at those 10 small pieces and you can't figure out for one case is there are no small pieces, right? Like you said, you can't do it small, right? That's when a rewrite is good. But the other case is if you look at it and go, I don't know how long it would take to try to refactor this code. You know, I might spend 6 months on this code, and it's still all messed up. Whereas I could say, I'm going to spend a year rewriting this app, and I know a year from now I will have this app working properly. So for me, it's about time. It's about predictability, right? I'd rather take a year and have a predictable result versus 6 months. Than in 6 months may not be any better than it was today. And then I might say, well, how about another 6 months? Okay, well, let's try that. And then you still may never get anywhere, right? So sometimes to me, the rewrite is, at least it gives you a predictable outcome, a much more predictable outcome.
So I think one success story I remember having is whenever I keep using this statement, the logical equivalent. Like we're refactoring this to achieve the logical equivalent but increase performance. What does that take? And you can kind of like go from there. Is in your 20-year-old case, your 20-year-old application thing, did you guys ever have a discussion where you're like, there's an easy road and there's like a hard road, and the easy road is like just make wrapper interfaces for all the logic that's related, and then just use it as a new interface? Is that like a method you use? Because I use that dirty method like a whole lot of times. Like I was gonna drop an album because I was rapping so much.
We did slowly start wrapping like the old code in, like you said, newer interfaces, because you're right, that is the easier road for that 20-year application. Because the problem is how do you take where you have new code that's like using OOP and all this other stuff when PHP 20 years ago was procedural. Like there was no real idea of OOP back then. Like it was kind of blossoming-ish. It was kind of like there, but the community was very torn on whether or not to use it. And in this case, the part of the community we were a part of was no. And so we ended up, everything was a function, but that kind of made our lives easier where now if we make objects, we can then just wrap those functions until we get the time to move the logic actually out of the function into the class and into a more modern state.
And then I have a follow-up now too. Which
Sure.
do you find was easier to refactor, objects or functions? Because this is tied right off that, and I'm in the function category, right? Like if it doesn't have state, I ain't even touching it. I'm curious.
The problem is like almost all of my background's objects going from procedural, but I think now that I'm in like the Golang world is where I'm thriving right now. So like where I work, it's almost all Golang, and that is object-oriented programming. I mean, it is because it has like structs, and you can attach functions to structs to be methods, but it has definitely taken me to a more functional state. I'm gonna say, if you don't have state, functions. If you have state, put it in a class. But then that's when I've also learned that when people say object-oriented programming, when you go and read a lot of the books, they even kind of say that. Like, not everything should be an object. Just because you can doesn't mean you should, but you want to know what Java did? Everything's an object.
Everything complex.
Mm-hmm. Yep.
What would be your biggest tip to help happen to avoid happening to the major code factors, or some of the tips?
Ooh. Okay, so you're saying like in like the stance of like a very large company.
Well, just in the stance of you're writing code, like what are some of the things that will help you avoid getting to a case study 3 scenario, you know?
Hire good developers.
Yeah, it's going to be one of those, monitor your tech debt, manage and maintain your tech debt. Like just, a lot of companies, they are always pushing feature, but then it's like, problem is every time you add a feature, there was some corners cut to hit that feature's deadline. I can guarantee it, because you didn't give your developers infinite time to work on that feature. So there's some edge case or there's some other thing, that you missed and you're just kind of living with it with like a workaround that's like, hey, this should have been done this way, but we didn't. Like I've worked for a lot of companies at this point, and every one of them have handled it different. And probably my favorite one is 10% of your sprint is resolving tech debt. So the PM can put as much features as they want, but the team is going to be like, well, this sprint, we got to remove like these 5 things, because those 5 things are going to be, we're removing tech debt, right? So clean as you go, and also maintain like a level of standards and quality in your code. Because that's another thing, is a lot of people, like there's a lot of times I've worked with developers that will set up like GitHub. They'll do like the GitHub actions for linting and tests and all this other stuff. But as soon as it starts getting in their way, that's when you see like a commit that says disabling this rule. And it's like, why? Ask why anytime someone is disabling a rule. Now, if it's something that's like, oh, the new line at the very end of a file, if your company cares, okay, keep it. But if you don't and the rest of the team don't, remove it. Like, I'm not saying like your linter should be and your test should be like very strict, but it should work for you and your standards. So it's like whatever your company's code standard is, set that bar, keep it there. It can go up, never down. I mean, we kind of do the same thing with food, right? If you go to a restaurant, when the quality starts going down, do you keep going to that restaurant? No. Not unless you're really diehard.
The one thing I would add to your, I thought your talk was really good. I think the most important point that I got is, you reminded me of, is refactoring is going to produce issues.
Mm-hmm.
You know, there's going to be new bugs, so always try to have tests beforehand. Like, it scares me to death when I try to refactor something that doesn't have a unit test. I'll refuse to do it. I'll be like, no, we got to write the unit test first, because we're going to, you know, no matter what your best intentions are of refactoring, you're probably going to miss some cases. And if you don't have tests to catch those cases, you're going to introduce bugs, and your users are going to be upset because they're going to be like, hey, you know, why is this thing broken? There's no new feature here. You know, why did you do something that makes it worse? Because from their perspective, it looks worse. So anyway, that's what I
Yeah. So I just realized what time it is. We got about 4 more minutes. So this is usually.
4:15.
Oh, do we have till 4:15?
I think we do. Does anybody know?
I thought we had till like 4. Hey, cameraman, do we have till 4 or 4:15?
4 o'clock.
Boom. So we have about 3 minutes now. Last
So
question.
are you primarily using like Selenium to automate your test cases? Like, is your surface area just like a web page, or do you have like a backend you can test?
So Selenium was for if we had like a front end flow. If it was an API, we would just hit it using basically curl.
Oh, okay.
Because you would set up the server and then your test would run, curl against it and be like, what am I getting out, right? That's like how you do end-to-end API tests. But nowadays, I'm actually going to recommend Playwright if you're doing front-end testing, because it has a lot easier of a flow to set up than Selenium, and it works with multiple languages now. So I think it's like Python, C#, and TypeScript, which I think also means it supports JavaScript.
Yeah, Playwright is awesome.
Yeah, Playwright, because it'll do like the headless thing all without Selenium, so you're removing that overhead of having like a completely different API. And, yeah.
How do you manage dependency kind of issues where you have a lot of dependencies and that prevents you from updating something that causes you to update 15 other dependencies that have their own dependencies? It just goes on.
Priority
Like
list.
modules.
It's basically when you see something's blocking you, then it's the ticket under that gets higher priority, and then just so on and so forth until eventually you find your highest priority and you work your way back down. Split it off into different tickets and split it up amongst your team, so that way as you're updating the dependencies and doing all that other stuff, you're kind of focusing on one at a time. If one is like dependent on a bunch of others, well, it's
Talk about like if you update one, like the version of your framework, you know, for example, it causes this domino effect that it's incompatible with a bunch of other ones.
when it's something as core as that, that's where you're gonna kind of run it like you're basically writing unit tests. So you're going to try to figure out where the code is that needs to change in order to fit into that new framework and set up one hell of a feature branch. It's where you're making those changes and then also upgrading the framework, same one.
Or
Before you have like manifests and stuff, you have like your JSON package managers, they should have a lot of the dependencies listed on there, right? So you just have a dependency diff, and then that could help you.
Well, it doesn't help if there's like, you have 3 packages that have the same dependency, but different versions of that dependency.
Yeah.
And one doesn't work with less than 2.6, and one doesn't work with more than 2.5.
Yeah, so whenever you get it, you get it.
Yeah, that's a mess.
Yeah, but then he's asking, how do you address that? Not how you find it, but how do you address it?
That's a mess.
Yeah.
You're in a rock and a hard place, really.
Especially
You
in
do the recursive dependency thing, and then you work from the bottom up order.
And
Yeah.
NPM's pretty good about that because it can do a sub-dependency in one version and then a different dependency over here in a different version.
Yeah.
But the Microsoft one, somehow it escapes me at this moment, but the one for C# is not very good at that. You
You
have
can
to
always
use,
become a core contributor.
you have to use the same version of all your dependencies.
Well, the situation we were in was we were using like one of those Angular 1 dot something, but then we had so many dependencies that were tied to Angular 1, and then just updating to Angular 2 was like impossible without a full rewrite because all those dependencies were for like, so Angular 1 to 2 was like a jump between, it was basically a new framework,
Yeah.
and then every version since it's like, you know,
Yes.
different. It's like
Yeah, 1 to 2 it's a fundamentally different product.
Yeah. So that's the problem we're in. We'd have to do the whole front end to fix it.
We can.
Like Docker containers, isn't that one of the things that we're trying to fix?
So we're actually at time. So if you want, you can find me after this if you want to like pick my brain a little more. I actually have like another pattern for you that I've used in the past that might help with your dependency issues. But so just so like we're wrapping up, is there any talks that somebody wants in the near future from this meetup?
Would anybody be interested in like interview type topics? Maybe fundamental software development stuff like sorting or anything like that? Maybe or big O notation, that kind of thing? We talked on that too. That's just a thought.
Yeah.
It's also, we're looking for stuff that's technology agnostic, right? So we don't just address the one person in the room who does that technology.
You like Postman, like using Postman? What do you guys are?
Yeah, that would be, okay, yeah, that's a good, speaking of.
Would you be interested in giving that talk?
I could.
Okay.
Postman is a really good tool, like you were asking about testing APIs. Postman does a really good job at automating API tests.
Yeah, I've done a lot of that. I was going to say I could do a demonstration on Postman or Python. I haven't used Playwright, though. That would be interesting to learn that stuff.
Yeah, Postman's pretty good.
Cool. So we have Postman, Playwright. Any others?
Techniques there.
Interview techniques, yes.
Fundamental software developer stuff.
Fundamental software developer stuff. Okay, cool. Because I'm the stand-in today. Usually Josh Copeland handles this stuff, so I'm going to be taking these notes down. I'm going to send it to him. But thank you for coming out.